Hello children, today we'll study about the equations of motion. Equations of motion. These equations of motion are also called as SUVAT equations. Why SUVAT? Because S stands for the displacement of the object, which is measured in meters. U stands for the initial velocity, of the object, which is measured in meters per second. V stands for the final velocity of the object, that is also in meter per second, and A is the acceleration, that is measured in meters per second square, and T is the time, obviously the time in seconds. Now keep one thing in mind, that to apply the equations of motion, we are going to assume that the acceleration is constant throughout the motion. So we can apply the equations of motion only to the motion in which the acceleration is constant throughout the motion, or that is, the object is accelerating uniformly throughout the motion. Okay, so today I will discuss the first equation of motion with you. We'll see some easy problems on it, and in the next lesson I will take some past paper type questions on the first equation of motion. Okay, now to understand what is first equation of motion, let us first see the concept of acceleration. So suppose this is a straight path on which one object is moving from a point A to another point B. Now at A, the velocity of the object is u meters per second, and at B, the velocity of the object is v meters per second, and it is accelerating uniformly at a rate of a meters per second square, that is, the acceleration is a meters per second square for t seconds. So now first we'll come to the concept of the acceleration. Now keep it in mind that here the object is moving along a straight path. It is not changing the direction, and you know that velocity is the speed with a proper direction. Since the direction is not changing, we'll treat the velocity and the speed as similar quantities. Okay, so how do you define acceleration? Acceleration will be defined as the change in velocity divided by time. Now, in this case, what is the change of velocity? The velocity is changing from u meters per second to v meters per second. That means the change of velocity is v minus u for how much time? T. So, A is v minus u upon t. Now, I will cross multiply first. At is equal to v minus u, and I will make v a subject. So, v is equal to u plus at. So, this is the first equation of motion. This is the first equation of motion. Okay. So, let us see some simple problems on this equation. So, question 1 here, example 1. A car starts from rest. A car starts from rest and accelerates uniformly at 2 meters per second square for 4 seconds. Find the final velocity of the car. Find the final velocity of the car. Now, as I already told you, whenever these problems come, first take a pencil in the hand, read each word carefully, because each word may give you some hint in the problem, and write the data with a proper symbol. Now, a car is starting from rest. This is important here. Now, starting from rest means indirectly what is given to you? Starting from rest means the initial velocity of the car is given to you. U is, how much is u? Rest means the car has no velocity, it is stationary. That means u is 0 meter per second. Then it accelerates uniformly. Accelerates uniformly means surely this is a problem of equations of motion. And at what rate it is accelerating? A meter per second square, 2 meter per second square. That means A is equal to 2 meter per second square, and it is accelerating for 4 seconds. That means T is also given to you, 4 seconds. And what is asked to you? The final velocity of the object. That means obviously V is asked to you. V is equal to how much? So which equation we should use? Obviously the, yes, first equation of motion. V is equal to u plus at. U is 0, A is 2, T is 4. That means the final velocity of the object will be 8 meters per second. Okay with you? Anywhere, any doubt? So, again I am repeating, read the question carefully, keep the pencil in your hand, write the data, and first underline the important things which you fill in the problem, write the data with proper symbol, and then select a proper equation and do the substitution. And secondly, whenever you write the final answer, write it with a proper unit with it. Okay. Let us take the second problem here. A car initially moving with a velocity of 4 meters per second accelerates uniformly after 2 seconds. Its velocity becomes 10 meter per second. Find the acceleration of the car. Okay, now again read the question carefully. The car is initially moving with a velocity of 4 meter per second. It is accelerating uniformly. So after 2 seconds, the velocity becomes 10 meter per second. You want to find out the acceleration. So here, initially it is moving with 4 meter per second. That means what is given to you? Obviously, u is equal to 4 meter per second. Then after 2 seconds, that means t is given to you. T is 2 seconds. Its velocity becomes 10 meter per second. That means v is given to you. And you want to find out the acceleration. So, write the formula for acceleration in the form v minus u divided by t. So 10 minus 4 divided by 2. 6 divided by 2, that is 3. And what is the unit of acceleration? It is meter per second square. That means the uniform acceleration of the car is 3 meters per second square. Let us take one more problem here. So, example 3. A car is moving with a velocity of 12 meter per second. The driver applies brakes so that after 2 seconds, the velocity of the car becomes 8 meter per second. Find the deceleration of the car. Now here the word deceleration is used. What is the deceleration? Deceleration is the, yes, negative acceleration. That means the velocity of the car is reducing. So mark the important data. The car is moving with a velocity of 12 meter per second. The driver applies brakes so that after 2 seconds, the velocity of the car becomes 8 meter per second. You want to find out the deceleration of the car. So write the data with the proper symbol. Initially it is moving with 12 meter per second. So u is given to you. U is 12 meter per second. The driver applies the brakes and after 2 seconds, that means t is equal to 2 seconds given to you, the velocity of the car becomes 8 meter per second. So v is given to you. You want to find out deceleration, but deceleration is nothing but negative acceleration. So that means you want to find out the acceleration. So again, use v is a is equal to v minus u upon t. Now here v is 8, u is 12 and t is 2, which is minus 4 upon 2, or that is negative 2 meters per second square. But keep it in mind one thing, that if I write deceleration of the car, deceleration of the car will be only 2 meter per second square, because d itself means negative. So again don't write a negative sign. Okay. Okay, let us see one more problem here. Okay, so example number 4 here. A car travels along a straight path from A to B at A. At A, its speed is 10 meter per second. It accelerates uniformly at 2 meter per second square. At B, its speed is 18 meters per second. Find the time the car takes to travel from A to B. Okay, so here I'll just make a rough sketch like this so that I know what all things are given. So this is a straight path. On this straight path, say this is A, this is here B. So at A, the speed of the car is 10 meter per second. It accelerates uniformly. So the acceleration is given to you 2 meter per second square. And when it reaches B, its speed becomes 18 meter per second. So what you have to find out? You have to find out the time the car will take to travel from A to B. So write the data. Okay. So what things are given to you? The car is initially, that is at A. A is the initial point. So at A the speed is 10 meter per second. So that means what is given to you? U is 10 meter per second. Then it is accelerating uniformly at 2 meter per second square. That means A is given to you 2 meters per second square. And then when it reaches B, its speed becomes 18 meter per second. That means obviously what is given to you? V is equal to 18 meters per second. And what we want to find out is T. So again use V is equal to U plus AT. So let us make this T a subject. So T will be V minus U upon A. So V is 18, U is 10 and A is 2. So 8 upon 2, that is 4 seconds. That means the car will take 4 seconds to travel between A and B. Is that okay? So children, now what I'll do is, I'll give you some sums on this equation of motion, first equation of motion. I will not give you any answers. You will try. So in the next class, we can just discuss it. Okay. So example 1. So any doubt you have, we'll discuss in the next class. So a car starts from rest. It accelerates at a uniform rate of 1.2 meters per second square for 5 seconds. Find the final velocity of the car Okay. Then example 2, an object accelerates at a uniform rate of 0.8 meters per second square after 5 seconds of beginning of the journey. Its velocity was 14 meter per second. Find the initial velocity of the object. So just try out these problems as a homework, and whatever your doubts may be, we will surely discuss them in the next class. Wish you are understanding these concepts. Enjoy the day. Bye and thank you, children.